here we are.
Okay. Do you want a lot of explanation for this? Do you want just the answer? Because this one's pretty trivial, meaning it's like one that's just well known.
How do you do this one? So,
Well, the derivative of a constant is always 0.
oh,
So
forgot about that.
yeah, so in this case, it could be y equals, e, or y equals pi, it's always 0.
Derivative of the given function.
Okay. The derivative of a this is power rule. So if you're okay with that, I can snip this in and show
Sure.
you kind of the long way of doing it that becomes short as you do a bunch of these because you start seeing the patterns. Let me share my screen.
Mhm.
Okay, so the rule here is that if you're given y equals x to the n, the derivative dy dx is n x to the n minus 1. So you bring that n down in front
Mhm.
and you subtract 1. So notice how there's a 1 there
Mhm.
above the x. So the derivative is 3 times, and then that 1 comes out. It's 1x to the 1 minus 1 right there. And 1 minus 1 is 0. So it's 3 times 1x to the 0. X to the 0 is 1. It becomes just the 3.
Okay.
Plus the 36, but the derivative of a constant is always
0.
0.
So this
So
one
it's
is just 0.
So well, the whole thing, yeah, the derivative is just 3.
Oh.
So there's yet another rule here. If your function is c times x, the derivative is just c.
Oh, okay. I see what you mean. All right.
So whenever you're ready, you can share back again and we can look at some problems together.
There we go. All right.
Great. So the derivative of this is very similar to the ones we just did. Do you want me to talk you through it, or do you want me to share my screen and show you how to work through this?
Can you snip it in again?
Absolutely. Okay, I'll grab that. All right, so this time we're looking at y equals x squared plus 3x. The derivative is, for the first one, you bring that 2 down, x
Oh, yeah, in front.
to the 2 minus 1 power. Yeah, and you always subtract 1.
And that was just 3, and the other is just 0, right?
Yeah, so this becomes 2x plus 3.
And that's it.
That's the answer.
All right. 2x plus 3. All right. Submitting that. That's correct. Let's show the next one. Here we go.
All right, so do you see that? So I guess you want me to snip all these, is that right?
Yes, please.
Okay. All right, so this one, you have to do what I call a rewrite step. And a rewrite step here is to remember that 1 over x to the n is x to the minus n. And how does that apply here? Well, it's x to the minus 21.
Okay.
And we've not taken a derivative yet. Your derivative is, your f prime of x, or your derivative is negative 21 x minus 21 minus 1.
Oh, okay.
Which becomes minus 21x to the minus 22 power. Now, on some exams, they're very particular. They actually want you to only write it with positive exponents. So you'd write it like this, over x to the 22 power. And that's just undoing what we have up here in the top right. So I'm not sure what yours will accept. It'll probably accept either of these.
Yeah, I'll try it out. Let's see, negative 21. By x to the 22. And that's correct. All right. I'll share this one again.
Okay.
All right. I did derivative of this one.
Yeah, let me get a snip of that. Okay, so this one, a little bit of rewrite before you do it. So you can apply the square root of A over B as the square root of A over the square root of B.
Mhm.
So in this case, it's the square root of 1 over the square root of x to the 24th. On the top, it's just 1. Now the square root of x means x to the 1/2 power. So
Oh,
this is
okay.
x to the 24th to the 1/2 power, which makes this 1 over x to the 12th.
Oh, okay.
And then you can say, oh, that's really x to the minus 12. So somehow, and this is all prerequisite stuff, you have to be able to get to here from that. And you have not taken a derivative yet. Your f of x is x to the minus 12 power. So your derivative is minus 12x to the minus 12 minus 1 minus 12x to the minus 13 power.
That's bizarre. All right. I understand it though.
Okay, because you will get something like this on a quiz or a test where you have to manipulate it, rewrite it, as I say, to get to where you can actually take the derivative.
12x to the 13. It did. Oh wait, no, negative 13. That was my operator error. Negative 13. And there we go. All right. I'll share my screen for the next one. Share this one. Da, da.
Yeah, let me grab a snip of this. Okay, you're seeing my screen now. Again, probably can tell by now you're going to do a lot of rewriting, and it's a lot of exponent rules.
Okay.
So your y 3t to the 10, that's fine, minus 16t to the 1/2 plus 7t to the minus 1 power. Any questions on how each of these was transformed?
All right. So for t, the square root on the outside goes on the bottom for 1/2. Yeah, I see how it translates.
Okay, so now all of these are power rules. Now they have a coefficient. So your derivative is 3 times 10, because that 10 comes down, t to the 10 minus 1 power.
Okay.
So whatever this exponent is, you bring it down and you always multiply it. So like what you'll eventually do is you'll say, oh, it's 30t to the 9th. You will eventually do that. But for now, it's 10 minus 1.
This is 16 times 1/2. And
Times
that's
1/2 t, but you got to subtract 1/2 minus 1.
so that's negative 1/2.
Yeah, so it becomes 8t to the minus 1/2 power. This negative 1 up here goes with the 7, so it's plus 7 times negative 1 t minus 1 minus 1
Okay.
minus 7 t
t
to the minus
negative
2.
2. Okay. And then do we start rewriting the whole thing again?
Well, okay, on an actual exam, you could go either way. Like this is what I would want to see, because it demonstrates that you understand, college algebra, pre-calculus stuff, but your instructor should accept both. But that's a question for them.
No, I
And
think
if
that they accept this.
and if it's multiple choice, you could see some variations on these where you have to know how to move between them.
30 t to the 9th. Plus 8, which is divided all by root t. And minus 7 divided by t squared. Awesome. All right. I'll share my next one. Right about here.
Are you able to make that any larger?
Yeah, I can. Hold on. Here.
Yeah, I mean, unless you can zoom in on that, it's and unhighlight this stuff also. Just click off of it somewhere. There you go. Okay. Yeah, let me grab this. All right, so I'm going to share my screen and we'll get through this. So it says that they're giving you some function up here at the top. Great. Okay.
Mhm.
And part A is to find f of 4. So this is not a calculus step. This is just a put 4 in for t. F of 4.
Just 2, and then so 2 times 2.
Yeah, 144.
Okay. Just 144. All right.
Now to do f prime of 4, well, you need the derivative. So there's a small rewrite that you might do here, 72 t to the 1/2 power. So that when you take its derivative, when you want to find f prime of t, you take that exponent 1/2.
And the
T.
t to the 1/2 minus 1.
Right. So it becomes 36 t to the minus 1/2. And then it's good to start writing it this way.
Yeah, of course.
But then you got to plug in 4 for t. They don't actually want the derivative. They want the number.
Oh, okay. Then it's 2, and then it's 18, the whole thing.
Yeah. Yep. And then this one is take the derivative and divide it by take 18 divided by 144. Now they don't want that. They want you to actually reduce those. So what is that, 1/8?
I think so.
Maybe 1/8 there. Okay. The next part is, and maybe you got this on your first exam, is the interpretation where you have to write a sentence. So 4 years after farming in the region there are, so this wants f of 4.
Okay.
See that 4 years after farming?
Oh, all right.
The number of acres being harvested is increasing. So that refers to the derivative. That's f prime of 4, which is 18.
All right.
Or blank percent per year. So that's where it wants this last number, 1/8. Well, okay, I take that back because it wants it as a percent.
Mhm.
We probably have to convert this to a decimal, 0.125, and then make it 12.5% as your answer.
Let's see. It says that 1/8 over there is incorrect. So I think 12.5 maybe 0.125. Let's see if that works. There we go. It's correct now. Yep, 10 out of 10. There we go. All right. Share my screen again. Here we go.
It's odd that the last one had a black background and this one has a white background.
Yeah, this one's copy pasted from like a textbook or something.
Yeah,
And
yeah, the other one's
yeah.
interesting. Okay. Nevertheless, we will still solve these problems. All right, share screen. All right. So if by now you haven't figured it out, you have to take the derivative of like you're going to be taking derivatives for basically the rest of this class. So you should just get in the habit of taking a derivative. So the derivative of 2x squared is 2 because of that first 2. Bring the 2 down, x to the 2 minus 1 power. Okay, plus 6 plus 0. Is that clear how we got those?
Yeah.
Okay, so that's 4x plus 6 is your derivative. Now that's not what they want here, but you have to do the derivative. Okay, so they want the equation of the tangent line. The formula you always want to use for tangent line is point slope form. Y minus y1 equals slope x minus x1. And you need two things. You need a point and you need a slope. That's why it's called point slope. So your point comes from this right here. If x is 1, we need to find the y value. To find the y value, put 1 in for x.
You plug it back in. Oh,
To the original. Because
all
you
right.
want to point on the curve. So that's 2 times 1 squared plus 6 times 2 plus 7. That's 2 plus 12 plus 7. That's 20.
Okay.
So your point is 1 comma 20. Your slope comes from the derivative. Slope comes from derivative. That's really important to like associate, word association, slope, derivative, rate of change, slope, derivative, rate of change. They're all the same.
Okay.
So you take that x value and you also plug it into the derivative. So it's 4 times 1 plus 6, which is 10.
10.
So your slope is 10.
Mhm.
So the equation of your tangent line is y minus 20, because that's your y value, equals your slope. Your slope comes from the derivative 10, x minus 1.
Okay.
Now, sometimes instructors want you to simplify this. Usually they just take it as is. I have no idea what this will accept, but that's there. So I'm gonna just kind of re-snip. I'm just gonna restart the problem here because we got kind of a messy screen for this. But did you get that? You got that down, hopefully?
Yeah, I understand it.
Okay. I mean, you got it written down. So now for
Yeah.
this, for the -1, you need to do the same thing. You have to put -1 into here. So it's 2 times -1 squared plus 6 times -1 plus 7. That's 2 minus 6 plus 7. Did I? Okay. Yeah, I guess that's okay. So that ends up being just 1. No, it ends up being 3. 3. Yep. So when x is 1, y is 3. So our point is -1 comma 3. We need our slope. The slope comes from the derivative. The derivative is the same. The derivative is always the same. Okay, but this time you have to put -1 in for the derivative. So 4 times -1 plus 6, that's 2. So your slope is 2. Again, you need a slope and you need a point. So it's y minus y1, your y1 is 3, equals your slope, x minus x1. Your x1 is -1, so that becomes +1.
Okay.
That's it. You will get a question like this on your exam to find the equation of the tangent line.
Y minus 3 equals 2 times x plus 1. There we go. Can you scroll back up to the first one? Let's see. Oh, I put that as a plus. That's why. There we go. Submit that. No, it's still partially correct. Oh, what am I doing? Y minus. So y minus 20 equals.
Oh, it looks like it's 21. That will change it also. Please check me as we go. I'm tired and I make mistakes.
Yeah, me too.
Yeah, so that may be what's going on there. Hopefully that's fixed. Look at this one.
Still keep saying partially correct. Y minus y1 equals 10 times x minus. Did I not add something there? What did I do wrong? Yeah, 10x minus 1. Y minus 21 equals 10x minus 1. Yeah, I don't, it says it's incorrect for some reason.
For this first one or the second one?
The first one.
Okay, the derivative is 4x plus 6. When you put 1 in, you get 10. Great. X is 1. So when you get 2. Oh, the second one is 6. So that's 15. There it is.
That's y minus 15. Okay.
Yes.
And that's correct. Number 9. All right. Here's what they look like.
Okay. For a certain type of thing, okay. Correct units are A. Okay, can you just undo that for now? So let me just snip this and then grab that. Could you grab the drop down now? Could you click on one of them? Oh, I didn't like that. There it is. Okay, so I've got what I need. Now I'll share my screen and we'll work through it.
All right.
Okay, so the first question, part A, is to find the derivative. This decimal is no big deal. Like you have to be comfortable with decimals, fractions. You don't know what you're going to see. The derivative is 0.011. That 3 comes down, so times 3, x to the 3 minus 1 power. So that becomes 0.033x squared.
Okay.
So the units of x is centimeters. Okay, so A is in centimeters. I think that's what it's asking for. And then B is the output. I'm sorry. Yeah, the output is in grams. What's the third one that it's asking for? C?
Yeah, for C, the correct units are.
So C is like A, it's the input, so it's also in centimeters.
Jack, I need your help. On the
Let me
So
know when
for
you're ready
D,
to
I'm
D.
good.
Okay, so for D, this is where it's different. It's the Y units over the X units. It's really like B over A. So it's grams per centimeter.
All correct. Number 10. All right. I don't know why is it doing that? Come on. There we go.
Okay, yeah, let me snip this in. Can you click on the drop down under this means that? Okay, yeah, let me grab that. Where's my snipper? There it is. Okay, I got that. All right, so let me share my screen and we'll work through this together. So you might get a word problem on an exam. They don't always emphasize that as much here. If the air temperature is 20 degrees and the wind is blowing at 15, what is the wind chill? Okay, so this first piece of information is not useful because they're telling you, oh, it's all for that. This is what you care about. That's your V. They're saying V is 15. So the first thing here is literally just asking you to put 15 in for V. 48.17 minus 27.2, 15 to the power of 0.16. So you definitely need a calculator for that. I will do the calculation also. It says to round to the nearest degree. So I get about six degrees.
Okay.
Does that work? Did you get that as well? Is that
Yeah, I did.
okay? The next one's asking about the derivative. So we got to be able to take the derivative of this thing. So it looks complicated, but what is the derivative of a constant? 48.17. The derivative is 0 minus 27.2. And then you bring the exponent out in front. So it's 0.16 V to the 0.16 minus 1. So whenever you see something that doesn't look great, try to just follow the rule. Like don't overthink it here. So now you want W prime of 15. So that's minus 27.2, 0.16. Instead of V, it's 15 to the power of minus 0.84. So if you got a calculator handy,
All right.
So you should see the pattern here. Sometimes you're being asked to put the number in for X. Sometimes you're asked to take a derivative and then put the number in for X. This is you're gonna see this over and over again in this class. So I get here negative 0.447.
I get the same.
Okay, now we can grab the last part here. It says at 15 miles per hour, an increase in wind speed leads to a yeah. So the correct answer is B. It's about matching. I think it's B. Hopefully it's B. It's about matching the units. So it says 1 mile per hour.
Mhm.
If you look at the input variable, that's what that is. That's your kind of your X there. And this is your change is in the Y variable, which is the wind chill temperature.
All right, I'm selecting them. That was correct. All right, share my screen for the next one again.
Okay, let me snip this in. All right, again, you're given a function here. It says that C equals f of m, and f of m is the 17.4 m to the 0.25 power. They first want you to find f of m. That's your derivative. That's your power, f prime of m. That's your power rule. So that's 17.4. Bring the exponent down times 0.25 m to the 0.25 minus 1 power. Now it says the exact answer, so that means, no rounding. It means you probably can't leave it in this form. You actually need to multiply these things out. So that's 4.35 m to the negative 0.75 power. That is your derivative right there.
Okay. So that's the whole thing. So
that's this first box. Did I not snip in everything? Because it seems like it's part B is referring to some other stuff that's not here.
I didn't scroll down all the way. That's my
Okay.
bad.
So f of 71, this means to go back to the original function and put in 71 for m. That this is 17.4 times 71 to the 0.25 power. And they want 3 decimal places. Okay, so I get 50.508 for that.
Well, I'll screen share again real quick.
Well, it just, you can just read it off. It's probably f prime of 71.
F of m means for a human mass of 71 kilograms, the circulation time. I think you'll want to see this.
Well, it's just matching up these labels, right? Like
Oh.
m is kilograms, time is c.
So basically, for a human of mass 71 kilograms, the circulation
Exactly.
time is changing by f of 71 seconds for a 1 kilogram increase in mass.
You can go with that. I mean, but does it also ask for f prime of 71? Or not?
Yes. it
Okay,
sure
so
does.
let's at least get that before you share your screen again. So that means you're taking the 71 and you're putting it into the derivative. You're putting it into this one right here.
Oh,
4.35, 71 to the minus 0.75 power. So like I said before, I mean, it's you're going to calculate a derivative. You're going to evaluate the derivative. And that is a lot of what you're doing in the rest of this class.
sounds good.
So the answer here is 0.178. 178. What I get here. Why that's written poorly.
Is it basically just the same thing, or is it like one sec? Oh wait, so for a human with a circulation time, nope, that doesn't work. For a human of a mass 1 kilograms, the circulation time, I think I'm gonna try the same thing. It's partially correct. Which ones did I not get right? Oh, for the first one. I'll change that. Try it. Come on, let me edit. All right, there we go. On to the last one.
Okay. All right, let me grab a few snips here and then I'll have you move things around a little bit so that I can get everything in here. Let's do one more of this. I got, so can scroll for C. Can you see what's down below C? Can you just scroll down just a tiny bit? Oh, that's it. Okay.
Just more or less.
Yeah, I've got I'm almost there where I've got everything. Okay, we'll share my screen. All right, share screen. Okay, so it says the yield of an apple orchard measured in bushels of apples per acre. What is the yield if 4 pounds of fertilizer is used per acre? So this is just asking you to plug 4 into the original function.
Oh, all right.
F of 4 is 310 plus 140 times 4 minus 7 times 4 squared. So I get 214 for that.
Okay.
Part B asks you to evaluate the derivative, but you first have to find the derivative. So the derivative of 310 is 0. The derivative of 140x is just 140 minus 7 times 2x to the 2 minus 1 power. So that, and that's all from up here. So that reduces to 140 minus 14x. And part B is saying, okay, well, plug 4 in to the derivative.
Mhm.
So that's f prime of 4. That's 140 minus 14 times 4. What is that? 84 on that one. And then in terms of apples and fertilizer, so your units of Y is bushels of apples per acre and fertilizer in pounds per acre. So it's going to be something like bushels per pound. Is that an option?
Bushels per acre per pound of fertilizer. And there's bushels per acre, then pounds of fertilizer per acre, and then pounds of fertilizer per bushel.
Okay. Well, I mean, maybe try. I don't know. It should be bushels per pound. I don't. Maybe I didn't hear them all. So this will go up, and it goes up because the derivative is positive. It's strictly based on the sign there. So that's 84 bushels because of these numbers match right here
Mhm.
when you're doing it.
Then for the last one, it should be what is it? Blank should be used because of blank.
This one's like a business calculus problem, I think. They're like asking if you're at the max yet.
Mhm.
Minus b over 2a, so that's minus 140 over 2 times minus 7. 14 is no 10. Is that 10? Yeah, 10. So you're only using 4, and you should use you really want to go up to 10. So I guess more because something over here will go up.
All right, I just tried it out. It's more and more for both of them. And
Okay,
then for the first one, 214 isn't correct for some reason.
okay, well check my numbers here. I mean,
All right, I'll go over it. Hold on. Let me get my
4
calculator.
pounds of fertilizer, 310.
So 870 minus.
Oh
So
yeah, so I typed this into the calculator wrong. 140 times x, so I got 758.
oh, okay.
That looks like it'll work.
And that is correct. That's everything I wanted to do today, Matthew. Thank you very much for
Great.
your time.
Have a great night. Bye now.
You too. Bye-bye.